Welcome to this session on Introduction to Statistics. In this session, in continuity to the previous session, we'll try to delve a bit deeper into what do we mean by statistics and why is it important from the context of business organizations, or for that matter of fact, any organization. So to begin with, let us try to understand the learning objectives of this session and get a better understanding what all we'll cover in this particular session as well as then the next session. Now the first objective, learning objective of this presentation or this session is to list the different ways in which statistics is used. This will give us a better understanding or help us understand in a better manner that why it is important for us, because it touches our lives in various ways. In day-to-day life also, you will find that statistics has relevance as well as in professional life also. The second learning objective is to know the differences between the descriptive and inferential statistics. So broadly, there are two classifications of statistics, which is the descriptive and the inferential. So we'll try to understand, learn about that. What do we mean by these? The third learning objective is to understand the differences between a sample and a population. What do we mean by population and what do we mean by sample? Where and when sample should be used? We'll try to develop better understanding about that. The next learning objective is to understand the differences between qualitative and quantitative variables. In statistics, often we use various kinds of variables and they're classified as qualitative and quantitative. So that we'll see and understand that what do we mean by these terms and what is the difference between the two kinds of variables which are used. Next learning objective is to compare the differences between the discrete and continuous variables. So variables are also classified as discrete and continuous. One way of classification is the quantitative and qualitative variables, and another way of classifying variables used in statistics is like discrete and continuous. So we'll try to understand about them and what is the difference between the two. Then if time permits, we'll try to cover this. Otherwise, in the next session, we'll try to understand this concept, which is very important to understand the levels of measurement in data which is used in statistics. So we'll cover all of these in the following slides and get a better understanding of it. To begin with, let us try to understand that why we need to study statistics or why it is important. So as we can see that numbers are used everywhere, almost everywhere they exist. So you must have started your schooling and then 1 2 3 numbering came into picture, and irrespective of whatever subjects you studied, maths would have been there till you can say not only your schooling, but it continues in one form or the another. Mathematical, some formulas, at least the addition, subtraction, deletion, they continue. So it is very important, and when we have the numbers basically, so we need to analyze those numbers and get a better understanding of the related area from where the numbers have been drawn. And often you will see that these numbers help you. So if I take an example of your schooling, so you are graded or you get marks in your examinations which are considered to be a reflection that how well you have understood a particular subject. How many students in a class, again we are talking about numbers. How many students who scored above 60% or were the first divisioners. So again we are talking about numbers and trying to classify. So statistics is applicable everywhere, and the knowledge of various statistical methods which we are going to study in this particular course or subject will help us understand that how decisions are made, and how we can get a better understanding, or how we can develop a better understanding as to how the decisions affect you by using the different statistical methods, tools and techniques. So as I already mentioned, no matter what line of work you select, you will always find that there is a quantitative or data aspect there, and it will be used for making decisions. So hence we need to develop a better understanding of statistics or numbers. There are some examples which will further help you develop a better understanding, like why we are studying statistics and why it is important. So consider a research agency which is analyzing that different aspects related to stock markets, and based on analyzing the stock markets, it is advising that whether you buy or sell shares. So again, it will need that what is the pattern of movement of share prices over a period, and make a forecast. So basically we are analyzing the numbers, basically the prices fluctuations over a period of time, and then trying to make a recommendation based on that. So in financial domain, this statistics helps in analyzing the data. This is an example of such a case. Now if we consider from the marketing perspective, then maybe an organization is wanting to launch a new product, such as Colgate Palmolive might want to manufacture and launch a new soap, a range of soaps with fruit smells. So before launching it, they might want to test the market, or identify the potential for um, such a product in the market. So they might conduct survey, then based on the survey they might analyze and get an understanding at how much this product is likely to be successful in the market, how much sales they can derive in times to come, if they go ahead with developing and launching this particular new product. So again, it is using the numbers, and trying to get make a decision based on those numbers. So statistics comes into picture here also. If we talk about from the government perspective, yes, government always, so we are analyzing our economy in terms of GDP growth, inflation, index of industrial production. So all these are based on data over a period of time, what data says and what are expectations, on what parameters or what variables the economy depends, and based on the condition of those variables we try to make a forecast, or how much will the growth of GDP be in the coming quarter or half year or year. So again, the numbers and statistics comes into picture from the government perspective. Even in today's context, when we are battling with the COVID-19 pandemic, so every day you will be hearing that these many cases reported, these many got well, and what has been the trend of in the numbers of people being tested, or traced as being affected by COVID-19. So all this is concerned with numbers and analyzing those numbers. So again, statistics comes into picture here too. And then the different managers might also want to take decisions about the quality of their product or service. So what is the customer's feedback, they want to assess how what they feel about the product, if they want any changes in the product or service. So all those aspects can be assessed by um, customer responses, and then analyzing those responses. So again, numbers comes into picture. So statistics is very much relevant and important for managers to understand. Having developed an understanding about why study statistics, let us try to understand what do we exactly mean by the term statistics. Though we have dealt in brief about this aspect in one of our previous sessions, but let's try to recapitulate and revise and get a better understanding about this. So in a, you can say, common parlance or common usage, statistics refers to numerical information. Wherever we have numbers or numerical information, in simplest terms we can say that it is statistics. So when we are talking about, say for example, the average starting salary of college graduates, or we are talking about what is the trend or what is the number of deaths related to alcoholism, or maybe even traffic road accidents related fatalities, or the changes in the Standard and Poor's Nifty, that's the Indian Nifty stock index, on a day-to-day basis, or how much, even for that matter of fact, in sports and games, like how many runs were hit by the Kolkata Knight Riders during the 2000 IPL season. So uh, all these represent numerical information, and statistics is related. Now, we often present statistical information in the form of graphs for capturing and not only capturing reader attention, but to easily understand what are the numbers are saying. So typically plots you must have heard, like bar graph, pie charts, all these portray a large amount of information very effectively in the form of graphical notation. So often with statistics, graphical representation is important to understand. We'll study more about these various graphical representations in subsequent sessions. Now next, let's talk about the major classifications of statistics, or two types of statistics, which are the descriptive and inferential statistics. Now when we talk about descriptive statistics, what we mean is it is related to the methods of organizing, summarizing and presenting data in an informative way. So simply, when you collect the numbers and you represent those numbers, so you summarize and represent those numbers and present that, so maybe in a graphical form, or you say that the average, you talk about the averages like mean, median, mode, then what you are doing is you're describing the numbers. So it is what is we mean by the term descriptive statistics. For example, for your class, if we say that the average percentage marks scored by the class is, say, 70% or 65%, so what we are doing, we are describing the average for your class overall percentage marks scored. So it gives what is meant by descriptive statistics. Now when we come to the another type of statistics, which is called the inferential statistics, uh, what we mean is that a decision, estimate or prediction or generalization about a population is made based on a sample. So take in a simplest example, like for example your class is there. So there are, say, 65 students in section A, and around 65 to 70 students in section B. So often what we need to do is, for example, we try to assess that how much uh, they would like to go on a trip to a particular place. So one way is that we ask each and every student of a class his or her opinion, and then take a call. And at times it might happen that all are not available, and approaching each and everyone and then collecting information might be. So just to take a decision that whether we should plan for an outdoor trip at the beginning of a semester, once the situations normalize, so we might want to take some samples. So few students randomly from your roll numbers, based on that we select few students, and then ask them that what do you think about arranging of a short trip, outdoor trip. So, and based on that, those responses, say suppose section A has 65 students, so we say that we'll take responses from 20% of the students, say 1/5. So roughly about 13 to 15 students, we ask the question and take the responses, and these 15 students are selected randomly for your roll list, and based on the opinion or response of these 15 students, we generalize, or we predict, or we estimate that what the people of the class are interested in such a trip or not. So what we are doing is, based on a small portion of the students, we are generalizing a decision, or for the applicable to the entire class, or for to both the sections. So this is an example of inferential statistics. So basically what it means is, we, instead of all population, that is total population, all the students of the sections A and B, we take a small portion of the students, ask them, and then based on that response, we generalize that okay, the class sections A and B have this opinion about a particular aspect. For example, we just discussed about planning for an outdoor trip. So this forms what is called as the inferential statistics. Inferences are drawn basically based on data, what data is saying from a sample. Now it is important to note that in statistics, the word population and sample have a broader meaning, and a population or sample may consist even of individuals, like in example we just discussed about the students, some of the students in a class, or it can be also about different objects. So population and sample have a very broad meaning. It can be applicable to individuals or different objects too. Now further delving into what is population versus sample. So a population is a collection of all possible individuals or objects or measurements of interest. So for your class, if each and every student is involved in that in a particular study or survey, so it will be a case of population survey. And when we select a small portion or part of the population of interest, then it will be a sample. Like in the previous example we just discussed, out of 65 students in section A, we collect responses from a sample of 15 students, which can be chosen on various by different means. You will learn about the sampling, various sampling techniques later on, but say if 20% randomly selected 15 students around are selected randomly. So out of the total class, 15 students from whom responses were, so these 15 students represent the sample, whereas the all the students represent the population. Similarly, is you must have seen that when we are nearing an election in a state or in a country, so what is done is often in tie-up with various marketing research agencies, often the news channels cast an opinion poll. So what they do is, in a particular city, they do not approach each and every voter, but rather from select few voters they take the responses, and based on that they predict that how many seats a particular party or a particular contestant will win in an election. So this is again an example of using sample and then inferring based on drawing inferences based on sample. So it can be found in various ways also in a business scenario also. For example, you are trying to assess the potential of a new product in a market, then you, in a city, you might go to certain locations and try to take a feedback from few of the customers chosen randomly, and based on those responses from few of the citizens, so you generalize that the sales likely to be whatever x amount of number of products in the first year, and so on. So often collecting data from the entire population is not very practically feasible. It is cost intensive, so it is prohibitive of cost if you include or collect data from each and every individual or object in a study. And at times it might also involve that a destruction of item happens if you conduct the study. For example, say suppose you are manufacturing say tires, and business organizations like MRF manufacturing tires, or C8 manufacturing tires. So you might want to test that how many kilometers a particular tire can be used for, how many thousands of kilometers. So what they generally do is, if we test each and every tire being manufactured, so it will lead to destruction. Means the tires will be run, and then you won't have any products for sale. All will be used for testing. So rather, for testing, what it does is, so randomly from a manufactured lot, a few of the tires are chosen in a sample, and those tires are run and tested, that how long will they last. Based on that, the prediction is made whether it's 65,000 or 80,000 kilometers run these tires can have, and that figure is quoted for the entire lot. So in this situation also, this example also illustrates why we go ahead with sampling and not with the population study. Uh, so using a sample to learn something about a population is very extensively used in business context, in agriculture context, in politics, government. And an example, again another example is that the television networks constantly monitor the popularity of their programs, and this is done often by hiring the marketing research agencies like Nielsen, um, or others, and they sample the preferences of TV viewers. Instead of each and every viewer, they go to randomly to some of the viewers and then collect responses from them. Based on that, the popularity is assessed of a TV channel or a program. Now the next important concept is the concept of qualitative and quantitative data, now variable. So often we will find that we have two major categories of data or variable, which is qualitative and quantitative. First, the qualitative or attribute variable, as they are known as, it represents the characteristics being studied as non-numeric. So whenever non-numeric aspect or characteristic is being studied, it is what is called as qualitative aspect or qualitative variable, or also attribute variable. For example, when we talk about gender, so gender is male, female, or we talk about religious affiliation. So whether your religious affiliation is Hinduism or Christianity or Sikhism or Jainism or Buddhism, all these classifications, or even Islam. So all these classifications are an example of qualitative attributes. Now, type of automobiles owned, whether you own a bike or a bicycle or a scooter or a car, so all these aspects are uh, what we can qualify as qualitative. Now, in which state you were born, or your what is your the color of your eyes, all these are examples of qualitative variables. Now when we are talking about information which is reported numerically in terms of numbers, 1 2 3 4 like that, or even points, 1.2 1.5, so all these are what we call as quantitative variables. For example, when we check, if you want to check your balance account in a bank account, so that will be in terms of these many rupees, whatever. So that will be a precise number. So that is what is an example of a quantitative variable. Then suppose we want to talk about how many minutes are remaining for the class to conclude. So then again there will be some number, say 10 minutes are remaining, 20 minutes are remaining, or 12 minutes are remaining. So that is again an example of a quantitative variable. And if another example could be that if we talk about the numbers of children in a family, so whether there are one children, two, whether there is one children or two children, so that is a precise number which you are talking about. So again, that is an example of a quantitative variable. Now another classification is when we talk about the classification of variables. So it is, the variables can be classified as discrete and continuous. In the previous slide we discussed about the classification of variables as being qualitative or quantitative, means non-numbered or numbered. Another way of looking at the variables is from the concept of discreteness or continuity. So what do we mean by discrete variables? So there can be some variables there in a study, there can be some variables which assume certain numerical values, and there are usually gaps between them. For example, the number of bedrooms in a house, so it can always be like one bedroom a house has, or two or three or four or five, so on and so forth, but it cannot be 1.5 bedrooms or 1.25 bedrooms. So there are gaps between 1 and then 2. We immediately move to 2. So there are precisely whole numbers which are involved, 1 2 3 4. So similarly, how many members in a family? There can be 1 member, 2 member, 3 member, 4 member. It cannot be like 1.3 members. So after 1, either you will have 1 or 2 or 3 or 4, but not anything in between. So these whole number values, when they are there, that is an example of a variable which is a discrete variable. In contrast, there is another kind of variable which is a continuous variable, and it can assume any value within a specified range. So suppose we talk about the weight of yours, so it can be 62.5 kgs, 62.3 kgs. So it assumes not only whole numbers, but it can be any number in between the whole numbers. Or height of a student, say 5 feet 10 inches, or 5 feet 10 and a half inches, we can say. So not only whole numbers are involved, but we can have in between like points, decimal places also. So this kind of variable, when we talk about, it is called a continuous variable. So we give this summary on the classification of various kinds of variables. So the different types of variables are classified as qualitative or quantitative. Qualitative means non-numerical, quantitative means numerical. The examples of qualitative variables are like the brand or PC you might have, what is your marital status, whether you're married or not, your hair color, black, brown, blonde. So all these are examples of qualitative non-numerical values. When we talk about the quantitative variables, then they are further classified into two types, which is the discrete and continuous. Discrete quantitative variable or the continuous quantitative variables. Examples of discrete quantitative variables are the number of children in a family, the number of members in a family, the number of students in a class, the number of strokes on a golf hole for, or the number of TV sets owned by a particular family. All these are examples of discrete quantitative variable, whereas the number will be a whole number, 1 2 3 4 5 6, but never in between like 1.2 1.3 like that. In contrast, the example of continuous quantitative variables are the amount of income tax paid by an individual or an organization, the weight of a student in a class, or the yearly rainfall in a particular area or city like Dehradun. All these can be in points also, means they are not only, they cannot necessarily be in whole numbers, but they can lie in between the whole numbers. So suppose height 5 feet 10 inches, so it is not like either a student will be only 5 feet or can be 6 feet, but it can be in between also, 5 feet 10 inches. So these are the examples of continuous quantitative variables. Now the different levels of measurements, I think this will cover in the next session. We have already covered a decent amount of aspects related to statistics to begin with. So we continue with the next session and talk about the different levels of measurements. Thank you for being a patient listener, and wish you a happy day ahead.